Hey everybody, it's Bruce and the dog on the floor, and today we're going to be working with nerves. Specifically, we're going to be building the circuit for our digital binary clock. That's just a clock that's going to count 60 seconds with 6 different LEDs, and it's going to count them in binary. So you'll see like the 1 bit on when it's the first second, and then the second bit on when it's the second, and then the first and the second bit on when it's the third, and so forth. And that's going to be a cool project because it's going to allow us to start to think about the hardware and to build a software model for that in terms of layers of our systems. But in order to do that, we're going to need a little bit of hardware, and this is what it's going to look like. So here I have some breadboard with the ground rail connected, and then I have 6 individual LED circuits that are all independent and that are all connected to different GPIO pins. So this is one particular pin mapping. I think that we're going to use a different one for the individual project, but it doesn't matter which GPIO pins you use. You just need to use one of them. But essentially, the power is going to flow from our GPIO pin, and that'll generate 3.3 volts. Through our resistor, we're going to use 100 ohm resistors. You could use anything from 100 to 500 ohms. And then that's going to flow into the positive leg on our LED, out the negative leg, and then to that ground rail, back to the ground pin on the Raspberry Pi. And so this is a pretty straightforward circuit, but it's going to give us enough complexity where it will allow us to think about our software and hardware and how they work together so that you could start seeing some of the benefits of Elixir when working with hardware. It's going to be a great time. Hope you enjoyed as much as I do. All right, so let's take a look at the shopping list for our digital clock. First, we need a couple of sets of jumpers. We need 6 of these male jumpers. Now these are going to connect the resistor circuit to our ground rail. And then we need also 7 of these female male pins. And so these jumpers are going to connect both the circuit to our GPIO, and they're also going to connect the ground terminal on our Pi header to the breadboard. And we have a couple of 100 ohm resistors. We're going to use 6 of these. And then we have 6 LEDs. It really doesn't matter which color. We're picking 2 yellow, 2 blue, and 2 red. You need 6 of them basically to get us to the resolution that we need for our clock, which is going to be a 60-second clock. And then we're going to need the breadboard. We're going to need some type of USB cable to connect you to the Pi, which is micro USB, to whatever your system connects. You also need the micro SD card so that you could actually burn the firmware and manage your shot. So I think that that's going to do it for the shopping list. Okay, so we're going to start this circuit. And this is what it's going to look like. I'm going to start with a resistor. I'm just going to make one of these, and then you can kind of see what it'll look like for the rest. I'm going to point the legs down like that. And then I'm actually going to span this chunk of breadboard like that. And so we'll drop that in like that. I think that's in there. Okay, so we're going to need 6 of those like that. And then I'm actually going to point the long leg towards the LED, and I'm going to cut across like that. And I'm going to do that a couple of different times. So I'm going to have 6 set up like that, but we're not quite done yet because we also need to pick up the GPIO pin with this one that's pointing to the long leg, right? So that female will go to the GPIO. And then we'll pick up a short jumper, and we're going to go ahead and connect to the ground rail. And so I'm going to pick up the same row for our LED short pin, and this is going to go straight in to the ground rail like that. And so that's what one of our LEDs looks like. I'm going to go ahead and give that a little bit more room. So that's what one of our LEDs looks like. And we're going to pick up a long connection from the ground rail. And this is actually going to go to the ground pin on the Raspberry Pi. So the nice thing is that we could have the LEDs kind of side by side, which is going to look nicer for the demo for our LED clock, right? Because we'll have the most significant bit on one side and we'll have the least significant bit on the other side. And so it'll help us to debug and be able to read this if these are side by side. So we're actually going to leave this right here, and I'm going to build off camera. I'm going to build 5 more circuits exactly like that after we verify that this one works. And I'll see you in just a minute. Okay, now let's test our single LED circuit. I'm going to SSH into nerves or circuits at nerves.local. Nerves.local is just a remote host. That's just the Raspberry Pi Zero. I'm connecting that with password circuits. So remember, right now, all that we have on there is the quick start for circuits. And I've built that for the Raspberry Pi, or the Circuits Quick Start project did. And so now I can alias the Circuits.GPIO. And then I can open for input an LED. And I'm using pin 26. You can use whatever one you want. And I'm going to open that for output. Right? Okay, I can write to the pin. And I'm going to write to the LED, and I'm going to write the value of 1. And this is just a reference here that refers to the pin. So that's how the libraries looked at it. So I can let that fly. And I'm going to press enter now. And look at that, the LED is on. And now I can do a GPIO write to 0. And the LED is off. So we have a working circuit, and we can go ahead and build 5 more just like this. So let me show you one of the tricks that I've been using to test this as I go. So I've been moving, so I know this pin is already connected and working. I can turn on one of the LEDs like that. And let me do that. I'm just going to write to the LED at pin 26. Let's plug this in the right place. Yeah, so you can see that that's on. And now that that's on, I can just quickly go down the list and make sure that my LEDs are firing. And they are. So now all I have to do is I'm just going to plug in some of the longer cables. I'll grab this one and I'll plug it in against this LED right here. Then I'll grab one more. And as I plug these in, this is going to allow me to essentially rapidly have a working circuit where all of these individual pieces are working. So they're verified to work. If I look at the Raspberry Pi with the memory card on the left-hand side and the USB pointing back towards me, then on the lower right, the end point is a ground, and the one right before that is 26. But I don't have to mess with all of these right now. What I can do is effectively just make sure the circuit end is working, and then I can debug the GPIO ports later on. And so that's the way that we're going to approach this. So the last step is to attach these individual cables to GPIO pins. And I'll do that, and I'll show you the ones that I've chosen. So that much is next. So now we're looking at the GPIO pins on the pinout.xyz. And you can see that we're attached to the ground right here on pin 29. And then the Broadcom pin 26, which is this one, we'll skip one and then use the next three. And then we'll have the Broadcom pins 13, 6, and 5. And then we'll skip a handful and then we'll pick up again with this pin 22. Or maybe we'll just use all three here. Maybe that's a good way to go. Or I'll tell you what, it might be easier to use 26, 16, kind of use these 6 available ones for our LED clock right here. So that's what we'll do. We'll use 16, 16, or 26, 16, 13, 6, 5, and 12. And then let's see where that takes us. So let's go ahead and I'll make those connections, and then I'll show you what the end product looks like, and then we'll wrap up. I'm going to shell in a second, but the pins that I'm using in order are 26, 13, 6, and 5. And then I pick up 16 and 12. And so what I'm going to do is just open up Circuits again, or open up my Raspberry Pi. And then I'm going to alias Circuits.GPIO. That's great. And now I can say pins is equal to, and then I just want to make a map. And I want to say 1 is going to be 26, and 2 is going to be 13. You know what? I actually don't need a map. Let's just, because I can build that map with code. So I'm going to say 26, 13, 6, 5 is the way I think it went. Let's take a look here. 26, 13, 6, and 5. Yeah, and the last two are 16 and 12. Last two are 16 and 12. Okay. And I'm going to say LEDs is equal to, and then I'm going to say enum.map, and I'm going to pass it the pins, and then I'm going to say, what are we going to do? So we're mapping over those, and we need a function, and the function is going to receive a pin, and it's going to return the GPIO.open of pin for output. And then it's going to pipe that much to element 1, right? Because this is going to be an OK tuple. Okay, so let's open all those out. Yeah, so I get a bunch of references back, so it looks like things went well. And so now what I want to do is enum.each, and then I'm going to pass it LEDs. Or actually, I'm going to write a blank function. So I'm going to say LED1 is equal to the head of LEDs. Right, so I have one of those, and I want to write a blank function. So blank is equal to a function that takes an LED. I'm going to say write, or GPIO dot write the LED, and I'm going to write a 1, and then I'm going to say sleep. I don't know, 200 maybe, 200, and then I'm going to write a, is that process.sleep? It might be. And then I'm going to say gp.write LED 0. And then I can sleep again. Okay, so that's my function. I'm going to end that. So now I can say blink LED 1, undefined function blink. Here we go. And you can't see it, but I can. It did that. So now what we're going to do is we're going to say enum.each, and I'm going to say pins, and I'm going to, I want to pass it LEDs, and I want to pass it the function that we wrote, blink. Okay. And I'm going to switch cameras so you can see what's happening. And I'm going to press enter now. I got most of them, didn't I? Let's see if I move something around. So I wonder if that's my little mangled resistor a little bit. I wonder if that's either pointed. So it's either in the wrong port. Okay, so this is the one at pin 16, and let's see if that's the right one on our pin out. So 16, and that should be this green. Now the blue one is wrong, huh? So let's see. So the blue one is number 5. Okay, so let's see if our LEDs are correct. So I'm going to make a list of my LEDs in the console. And then I'm going to make a list of the pins. 26, 13, 6, 5. So it's actually that third one. And I'm going to debug this circuit, and it looks like the one in pin 6 is the one that's messing with me. So that's this. I know that they run from 26, 13, 6, and 5. So this is the black one, and yeah, that resistor looks like it's kind of a tangled mess. So I bet it's not connecting well. So I'm going to fix that circuit up, and then be right back with you. Okay, so I wanted to show you the process that I used to debug this. So the first thing that I did. So first, let me show you the working circuit. But the first thing, so I know that it was the third one, so 1, 2, 3. This cable was broken, so I just moved this back to the third row to see if my pins were okay. And then you could see that that's actually blinking the first LED with that one, which is great. And then I knew, so after I was able to move this back and plug it into the circuit next to my resistor, I knew that it was the circuit itself that was bad, and my resistor just wasn't seated correctly. So we have a working circuit, and this is going to be the foundation for our digital clock. So it'll actually show in binary numbers the seconds from 1 to 60, or the minutes, just depending on how long we want to on how long we want to make the circuit. And that's really an excellent thing. For Bruce and the dog on the floor, this is Groxio Learning.